Hello, this is a short video about balancing equations. First, coming off of spring break, I'm going to give a little bit of brain teaser here. Feel free to pause it, but I'm going to go ahead and give you the answer. It's Lady Gaga. All right, let's get started on balancing equations. Remember, the law of conservation of matter states that matter is neither created nor destroyed in an ordinary chemical reaction. So because of that, whatever is on one side has to be on the other. Let me go ahead and give you a very simple example of KBr, potassium bromide, plus chlorine gas yields potassium chloride plus bromine gas. And I'm going to leave off the G's. Okay, so that's the equation we want to balance. The first way we're going to do it is something called an atom inventory. And that's where we draw a line and we list each element and how many we have. So we do them in order to make it very easy to keep up with. And then we just use the equation and see that there's no 1 in front of it. So that no number at the bottom, so we just say that's 1. There's 1 Br. There's 2 Cl's. And now on this side, we have 1 K, 1 Cl, and 2 Brs. Are they equal? The K's are equal. The Brs are not. To balance it, I must put a 2 here. So I'm going to multiply the whole thing. We only can use coefficients. When I put that 2 up here, I just messed up my potassiums, and I have to put a 2 there. So that's going to have an effect on this side. So I got to come over here and put a 2 to make them both 2. So now I have 2 potassiums, 2 potassiums, 2 Brs, 2 Brs. But when I put the 2 here, I also had to bring it down here to the Cl. The distributive property says it distributes across. So now I have 2 Cl's. I have 2 Cl's here. So now my equation is balanced with a 2, an understood 1, and some people like to put 1 there, and another understood 1 here. Again, you don't have to put that, but some people like to just to know all the coefficients. Now let me show you a different way that you could do them in your head. This is called balancing equations by inspection. This is my favorite way. Atom inventory has its purpose. And usually if I can't solve one within a minute, I go ahead and do an atom inventory. So okay, here we go. We're going to do the same problem, but this time we're going to try to do it in our head. We have how many K's on the left side of the yields? We have 1. We have 1 on this side. Yay, all is good. We have 1 Br. We have 2 Brs. So I got to put a 2 in front. Now I just messed up my K's. So I have to put a 2 over here. 2 K's and 2 K's. Now I've got 2 K's, 2 Brs, 2 K's, 2 Brs. Lastly, I got 2 Cl's. And because this 2's in front, I've got 2 Cl's on this side. Notice we have the exact same answer. This took around 10 seconds and this took about a minute. So I'm going to let you decide on that for the future. Let's try another one. This one we're going to try is going to be aluminum. We're going to take some aluminum. And we're going to oxidize it, obviously with oxygen. And we're going to make some aluminum oxide. Okay? So doing them by inspection, you would just look here and see that this 2 and this 3. 2 doesn't go into 3 and 3 don't go into 2. But luckily, if you multiply them together to get 6, you would need a 3 here to get 6 and a 2 here. And now you notice you have how many aluminums? 4. 4 aluminums here, 4 aluminums here. It's that simple. Now, we will get into some more complicated ones to balance. And let me try to give you one of those. Let's look at burning ethane. Now, this is going to be later on a combustion reaction. And so if I gave you this equation and asked you to balance it, could you do it? Now, at this point, I want to do a preface. You may need a pencil. And I'm even going to pull a pencil out to work this problem. Lots of kids don't like to erase, but this magical end of the pencil is called the eraser. You may need it if you balance by inspection or if you do it by atom inventory. So here we go. I'm going to go ahead and first work this one by inspection. I've got 2 C's. I've got 1 C. So I'm going to try a 2 here. I've got 6 H's. I've got 2 H's. Well, what if I put a 3 here? 3 times 2 is 6, and that's 6. 3 oxygens plus, I'm going to come up above this because I got 4 oxygens here, 2 times 2, and I have 3 oxygens here. So my total number of oxygens on this side is 7. Notice this is an even number. You will never ever make this even equal that odd. So guess what I have to use? That magical N called the eraser. I'm going to erase everything I've done except for the lines. I know without a shadow of a doubt that what doesn't work in the front? What was in the very front when we started? An understood 1. What number is bigger than 1? Well, let's just try 2. And again, inspection is a lot of guessing. If you don't like that, you may want to do the atom inventory, and we'll do that in just a second. Here we've got 2 times 2 is 4. So I'm going to try a 4 here this time. 2 times 6 is 12. So I'm going to come over here and put a 6. Now I'm going to come here for my oxygens and say 4 times 2 is 8 plus 6. 14 oxygens on this side. How do I make this side 14? By putting a 7 here. So you see I did have to erase on that one. Let's try that one again with the atom inventory. So I'm going to rewrite it here very quickly. And we're going to write down every element. Now watch closely how I write this atom inventory, because it really makes a difference. In just a second. Ooh, let's keep them in order. So let's do CHO. And notice that pencil's coming in really handy right now. So here we got 2, here we got 6, here we got 2, here we have 1, here we have 2. Now here comes the part that's difficult. This is probably the hardest part of balancing if you do an atom inventory. You've got 2 oxygens here. Leave a space and put plus, how many do you have over here? 1. If you combine those, it will really mess you up. Okay, so let's go through like we did last time and see what we try. We're going to try a 2 here. Well, now we got to put the 2 down here. Do you see what I mean? If you'd had a 3 there, it would have messed that up. Okay, so far so good. We got 2 and 2. Now we got 6 and 2, so we're going to try a 3 here. There we go. We got 6 and 6, but guess what we did with our oxygens? 3 there as well. So on this side we got 7. Can you ever make 2 and 7 equal? No! So guess what you got to use? That magical part of your pencil. So I'm going to erase everything and start all over. Erase the top. Some people don't like balancing because you have to erase. Some people enjoy it because it's almost like a puzzle and you're trying to figure out how to work the puzzle. Okay, notice I left the skeleton on this side. The 1, the 2 oxygens, and the 1 oxygen. That's okay to leave for now. So let's go over here, and we know 1 didn't work, so let's try 2. So now we're going to have 2 times 2, that's 4. So how do we make this side equal 4? We got to put a 4 in parentheses, which, goes up top. Now when we put a 4 there, you had to put it down here in the bottom. 4 times 2 is 8 on that oxygen. We'll work with that in just a second. But let's go ahead and look at our hydrogens over here. We started with 6, but we put 2 in parentheses for 12. How do we make this side 12? We got to put a 6 here. So a 6 there. Oh, yeah, I put that 6 down here. 2 plus 4 is 8. 2 times 4 is 8, plus 6 is 14. How do you make this side 14? Because it started with 2. You're going to put a 7 there. Yay! And if you notice, you have exactly the same answers. The atom inventory just takes a little bit longer. There's a bunch of these on the back side of your sheet. Also, I'm going to give you a website on the email. I want you to do 5 beginner, 5 intermediate, and 5 advanced. It's a great worksheet. Hope you enjoy doing this. And that'll be a lot of work to do in one day. Please don't do any more than that in just one day and wait. And we'll do types of reactions probably at least by Tuesday or Wednesday. Thank you and have a great day.